And we're live. Okay, let's see. Yes, mic's working. Okay, good. Hi, welcome back YouTube to this OpenFOAM video. I'm gonna continue our discussion in this pipe case. I mean, there are a lot of things you can do with a simple pipe case, as you have been seeing. All right, and a few things I want to note about since the last time. Actually, I forgot to change one of the boundary conditions for omega. At the bottom patch, the mixing length was not supposed to be 0.07, but actually much smaller, 7 times 10 to the power of -4. Because the whole case, the whole pipe actually shrunk. We shrunk the pipe manually. All right, so that's one that I will be uploading to Git again. We go to pimple foam. The other part is that I forgot to change the velocity because I forgot to change the velocity of the case because it's supposed to reflect the new Reynolds number anyhow. The new velocity, well, I intended to have was uref of 0.4. So let's do a 0.4 instead of a 0.1. That should give it a turbulent flow. And I should be doing the same for the Spallet Armora's case. And of course, after that, we'll be interested to see how different or similar these guys are in terms of friction coefficient. Okay, so let's do PU. Okay, what am I doing? Yes, I need to change stuff. This is a U. You change this. All right. So yeah, that's one of the things we need to take note of. All right. So what do we have next? Some of the interesting things we obviously, I mean, if you're running a simulation, we kind of want to collect data, right? We want to collect data. Okay, I have 2 turbulence models available now, and in fact I can sort of get rid of this template, okay, or at least replace it with something more updated. Okay, CPAR. You want to replace it with this K omega SST, pimple foam, template, rents. Okay, so that's the template file I want to use. Next thing, we know that we want to actually collect some data. So, excuse me. Yes, needed to skip. I was coughing a bit, but anyway, we want to collect some data. So we want to see how well do these models match up against let's say the common charts that we are used to, such as the Moody Chart, right? Moody Chart is over here. Right, this is the Moody Chart you probably see online. I mean, you can look at one from Engineering Toolbox, or you can like copy and paste a what do you call that? You can also look for a formula. Can't remember where it is, but yes, this is one of the ways. And of course, Moody Chart actually allows you to look for correlations relating to rough walls, and absolutely for K omega SST and Spallet Armora's models, you are able to do that as well, and we can explore that as well. I mean, there are boundary conditions. Okay, but I'm not going to go too much into that. The main thing I want to start us off with is this what do you call it? Yeah, I want to start us off with function objects. Okay, you may have know what functions objects are in the sense of it's there for you to collect data, and you'll find it in the post-processing part. Okay, you'll see lots of function objects. And what are the things that we want to compare? we want to compare, like for example, the friction factor, and of course, well, velocity profile we may not be as interested. We can take a look using ParaView, no problem. Yeah, so but we definitely want to have it calculate, let's see, we want it to calculate our surface, you know, the wall shear stress, right? We want to calculate wall shear stress, and hopefully we can also calculate the hopefully we can also calculate the friction factors as well, and compare them with, let's say, the Moody chart, and see which model actually compares better with the Moody chart. And by default, if you don't set a rough wall boundary condition, if you don't set a rough wall boundary condition, OpenFOAM will just assume it's a smooth wall. Okay, so there are lots of stuff you can do. You can check the Courant number using this boundary boundary object. Not boundary object. This function objects. Where am I going? Yeah, this function objects, and yeah, there are some things you can do. But let's see whether there are things such as this. Yeah, wall shear stress. See, we can see how these entries are written. Okay, for you see, where can we have this? This is actually found inside the control dictionary file. Okay, control dict file. So this will give us a few values of wall shear stresses, wall shear stress. And if you're interested, you can also see, you know, a y plus. You can get y plus written for you, which is pretty convenient. And these are the things we kind of want to take note of. We want to take note of for we want to take note of these values when we do this simulation. So let's do a wall shear stress and y plus, and we also want to see the average wall shear stress. Okay, because average wall shear stress is going to help us calculate our friction factor really well. Alright, so what do we have here? We have this wall shear stress. Alright, wall shear stress, and let's try putting this into the control dict file. Alright, go to intermediate plus. Let's see. Go to the. We'll just edit the k omega SST for now. Once we are done, we can then port changes over to the smaller Almaraz case. All right. So let's go to constant and system. Sorry. Should go to system, and we should go to the control dictionary. All right. I mean, there are lots of things we can do here as well, but let's just focus on wall shear stress for now. And if you take a look here, we won't see any function objects being being over here. So if you're not sure how to see how to do these function object things, how to insert function objects, or what it should look like, you can always go to the incompressible case and do your grep again, function objects. Okay, so you will see inside this control dictionary we have stuff here. Under the control dictionary, we have an entry for function objects in the comments. So let's go to this directory, and let's go to control dictionary, and we can see, okay, basically we have this entry called functions, and then of course they use this include, which is actually a C++ language. So basically they have all the other function objects in let's say in another file. So okay, great. So let's type something similar, functions, and open and close. Okay, and we'll save an empty file. What we have here is this wall shear stress function. So let's try having wall shear stress added So I'm just going to copy and paste and see what the output looks like. Okay, so good thing OpenFOAM is the Vim actually gives us a very good way to paste. You paste it very nicely. Okay, 1 2 3 4. Okay, good. So let's pry apart one of these what do you call that, this file. Okay, so the type of course is shear stress. We want to calculate shear stress, and the name of the function is called shear stress 1. Okay, and the library we use is the field functionObjects. We can see whether it's anything. Right, so these are some of the optional entries we can use. Which patch, for example, do you want to run this shear stress? Because you have to specify, you have to tell OpenFOAM, hey, I want to check out the shear stress on, let's say, wall A or wall B. Okay, so you can actually list multiple patches, okay, multiple boundaries, or they call it patches. All right, multiple boundaries, and we'll just put it under wall. Okay, we'll put it as wall. So the other thing is we have a write precision 8. I mean, you don't really have to bother too much. That's how many decimal points or something. That's basically what it does. Write to file, these are, you just like leave it as default. Region, okay, I believe these are for multi-region cases if I'm not wrong, but I don't want this, so I'll just comment it out. Okay, enabled, yes, true. Lock, I guess we could leave it as it is. No, I do not really want to leave too many locks. Okay, I guess I'll just leave it on first. Okay, time start. You can actually yeah, I can actually just delete this, because this one actually just tells you the time start and the end time. So I guess you could actually just put the $start time over there, a $sign and start time. Or okay, I'll just delete this. Yeah, this will make it, wait, no, maybe I'll just comment it out, even better, because this is actually pretty useful if you, let's say, want to start measuring your shear stress after some time. For example, if you have a transient simulation, and then suddenly, hey, I want to measure the shear stress after the flow stabilizes. So you want to give it some time to stabilize, and then you start measuring the shear stress. That's what is good for this time start and time end. Okay. So the execute control, I guess you can use time step. Okay. With a write and execute interval of 1. Okay. So what does a write? Let me go and check. I can't remember what this is. Okay. So anyway, yes, I may have forgot, but okay, the stuff is here under function objects and usage. It says how many steps per time do you execute. Okay, so you don't really need this. It's just there, like, I guess how many, I guess you kind of do this execution every X number of time steps. Okay. So time step is 1. I mean, writing it for every time step is kind of intensive. You may not want to do that, but you can do it every interval. Okay, you can change the control accordingly. If you use time step, it says it will trigger every how many time steps. Okay, over here, how many time steps. So if you use this time step, you'll trigger every X time steps, for example. Okay. However, if you want it to calculate every X number of runtime, you can as well. Okay, you can as well. Yeah, so I mean there are lots of options for you. I personally prefer adjustable runtime and runtime because it's most intuitive. And of course you can do clock or CPU time if your simulations take long, and yeah, if your simulation takes very long. Okay, so and the easiest thing is to use this write time. Okay, write time will trigger every interval output times alongside standard field output. Meaning to say, if let's say you have this this way you do time steps. I mean, here OpenFOAM will, because you set the right interval here as 50 with the adjustable runtime, then what you will print your data every 50 seconds. So if you only want your function objects to be executed every 50 seconds, so you don't like waste time and stuff, or you don't over accumulate data, you can do that, and that will be done using write time. Okay, so either use runtime, adjustable runtime, or write time. I really prefer write time. So I'll use write time in 1. Okay, write time, and I'll save, and we should be able to do a quick run with PimpoFOAM. Okay, so we can run for 50 seconds, or maybe just we'll run it for a short while. And I don't want to use a delta t of 1 times 10 to the minus 5. Maybe use 1 times 10 to the minus 4. Let it start up a bit earlier. Run it for 100 seconds maybe, and write every 10 seconds of time. Alright, and we'll have to run it a while. There's no shortcut over it for this, so I'll have to do an auto patch mesh generation. Alright, auto patch mesh generation, and then we'll have to do some running. Okay, so no shortcuts for this, but hopefully this will take a short amount of time. Okay, then we can take a look at what the shear stress is like. However, this actually will give us a field of shear stress values. Meaning to say, when you do something like this, okay, I'm not giving the correct. I'm not getting a discard. Okay, let's make a new one. Okay, that's better. Right. When you have your pipe, for example, when you have a pipe and you have all these mesh values, what this will do is that it will calculate the wall shear stress or tau wall at every single mesh point. So let's say this is tau wall 1, tau wall 2, okay, etc. Okay, so, and of course these meshes will always be some sort of a different area. They always have different areas to them. Then you're going to have a problem there. How are we going to find the average? Because ultimately we are interested in the average value of this wall shear stress. How then do we find this average? So to do that, we will need to have another function object. Okay, we need to have another function object. Okay, we need to have another function object in order for this this to work. Okay, but yeah, that's it. Like we have to do that. So let's do a PimpoFOAM and continue. Yeah, so that it will just start to run. Okay, so we'll let it run for a while. hopefully yeah, then next video or something we can like discuss results and add a few more function objects into the control dictionary file. Alright, so thanks for watching. I'll see you guys again. Bye bye.